Welcome to the video. My name is Pushpinder Gill and this is going to be my email address where you can send me valuable feedback. So today we are going to do permutations and combinations second video. So if you watched the first video, you very well understood that n things can be arranged in n factorial ways. We are going to build on that point right now in this video. So let's see. So if there are n objects, and I've already told you, if you want to arrange n objects in n ways, the answer is n factorial. However, what if out of those n objects, r objects are identical? So this is the point that we're going to elaborate today, and lot of questions which are believed to be very tough questions can be solved very easily if you understand this point. Okay, so let's go ahead and understand this point right now. So in how many ways can you arrange the word GMAT? Okay, so as you can see that there are 4 objects which you want to arrange, right? So you want to arrange GMAT, which can be pretty easily arranged in 4 factorial ways. You can put one of the arrangement would be GMAT, one of the arrangement would be GTAM. So like this, there can be 4 factorial arrangements, because we have already established in our previous video that n things can be arranged in n ways, in n factorial ways. So the word GMAT can be arranged in 4 factorial ways. However, if I ask you to arrange the word pen for me, P-E-N-N. So if you want to arrange the word pen, the total number of arrangements are going to be 4 factorial. Again, because there are 4 words, so the total number of arrangements are going to be 4 factorial. However, if we observe here, these 2 objects are identical. N and N, they are completely identical. So if let's suppose this is one of the arrangements, this is P-E-N-N, and this is also one of the arrangements. So even if I flip these n's, the word remains the same, which means that I have counted all these redundancies into this 4 factorial. So I have to remove that. So for me, in order to remove that, I have to remove all the possibilities in which this n have been mistaken for this n and this n have been mistaken for this n. Now it's very simple. If n objects can be arranged in n factorial ways, and out of them r are identical, so the total number of arrangements which are possible are n factorial divided by the number of ways these r things can arrange themselves, that is n factorial by r factorial. So whenever there are n objects, let me come back to the point. So whenever there are n objects out of which r are identical, the number of ways they can arrange themselves is n factorial by r factorial. So you have to take care, you have to understand this point. If you have understood this point, there are lots of questions waiting for you to be solved in an easy manner. So n objects out of which r are identical, the number of ways they can be arranged is n factorial by r factorial, because in n factorial you count many of them which are same. So to remove that, you have to divide it by the r factorial, and r factorial the number of ways in which these r things can arrange themselves. Okay, alright, let's go ahead and do some questions on it. Okay, now let us understand the arrangement. Now I'm going to show you one question how the arrangement works. So let's suppose this is A, B. You have to arrange A, B. How many ways are there to do that? So you can pretty easily say, okay, 3 factorial by 2 factorial, isn't it? So that would be 3 into 2 divided by 2, that is 3. So there are only 3 arrangements in which you can arrange A, B. So which is pretty simple. Either the word would be A, B, or the word would be A, or the word would be B, So this was pretty simple here. You know, these kind of questions you get in SAT, but not in the GMAT, not in the GRE, or not necessarily in the CAT. So you don't have to do this all the time. You can very well relate this here. Then how many ways A, B can be arranged is 3 factorial divided by 2 factorial. Why 2 factorial? Because these A and A can arrange itself in 2 factorial ways. Now, if you would have seen such questions. I bet you've seen some such questions. But what happens is the scope of this concept does not necessarily lie only in arranging the words. The scope goes beyond it. So let's see the scope of this concept. Let's see this question. So if R things are identical among n things, then they can be arranged in n factorial divided by the number of ways these R things can arrange themselves. So remember this point, and let's do some questions on these points. So let's see this point. In how many different ways 8 boys A, B, C, D, E, F, G, H can stand in a row such that A should stand to the left of D and E should stand to the right of G. Now, this question is a bit different. Now, there are no words here. There are boys standing. So, for your simplicity, I have made the boys to be A, B, C, D, E, F, G, H. Okay. So, these are the 8 boys. Now, the total number of ways they can be arranged is 8 factorial. Isn't it? 8 boys can be arranged in 8 factorials. They can stand in a line in 8 factorial ways. I think we already established that. Now, A should stand to the left of D. Now, we have to fix that A should be standing always to the left of D. That means A and D are identical here. You cannot swap A and D. You can't make A to stand to the right of D. Other way of looking at it is half the number of ways A would be standing to the left of D and half the number of ways A would be standing to the right of D. So I have to divide it by 2 factorial, right? Similarly, E should stand to the right of G. That means there is a condition on 2 words. That means I have to assume them to be identical and then I can divide it by 2 factorial. So this over here is my answer. So in how many ways 8 boys can arrange themselves, can stand in a row such that A should stand to the left of D? 8 factorial by 2 factorial. E should stand to the right of G? 8 factorial by 2 factorial into 2 factorial. Right? So I hope this was easier. Let's go ahead and solve some complex questions. In how many ways there to arrange the letters of the word success if the vowels should appear in alphabetical order? So let us go ahead and try to arrange the word success so that all the vowels should come in alphabetical order. Now, first of all, how many ways to arrange the word success? 1, 2, 3, 4, 5, 6, 7. So there are a total of 7 factorial ways for us to arrange the word success, all the letters of it. Now, as you can clearly see, there is a condition on U and E that E should be coming always before U because they should be arranged in alphabetical order, not necessarily together, but they should be arranged in alphabetical order. So that means I have to assume them to be identical. E cannot take the place of U and U cannot take the place of E, right? So in that case I have to divide it by 2 factorial. Now there are again 3 things which are identical, S, S and S. So these 3 S's are identical, so I have to divide it by 3 factorial, right? Similarly, these 2 C's are also there, so I have to divide it by 2 factorial again. That is what my answer is going to be. Easy, isn't it? You will be seeing lot of different cases, but this pretty much solves your answer in a quick. How many ways all the letters of success be arranged such that vowels appear in alphabetical order? So all the letters can be arranged in 7 factorial ways. Now the condition is on 2 words, U and E. These things are identical. They can arrange themselves in 2 factorial ways. Similarly, there are 3 S's. They are also identical. They have to be arranged in 3 factorial ways. Similarly, these has to be arranged in 2 factorial ways. Now by identical I don't mean same. By identical I mean that they cannot replace each other. If I put E in place of U, that will not be the case, isn't it? So by understanding this in such a way, you will be able to solve the complex problems even in a better way. When there are more than 2 words or when there are more than condition on more than 2 words, that will make your life easier back then. So let's solve some questions. Now this is a very tricky question. I see a lot of awkward explanations of this question over the internet. So let's try to simplify this. In how many 6-digit numbers can be formed using the digit 1, 2, 3, 4, 5, 6 without repetition, such that the hundredths digit is greater than the tens digit and the tens digit is greater than the units digit? Now first of all, 1, 2, 3, 4, 5, 6 have to be arranged. In how many ways do you arrange 6 letters in 6 ways? Yes, 6 factorial, isn't it? Now you just have to see how many things are identical here. Now you can clearly see the 100 digit has to be greater than the tens digit and the tens digit has to be greater than the units digit. That means indirectly hundredths digit has also to be greater than the units digit. That means these 3 words or the 3 letters or the 3 numbers cannot take their own positions, that they cannot interchange their positions. That means that 3 of the things are identical. So in how many ways these 3 things can arrange themselves? These 3 things can arrange themselves in 3 factorial ways. So my answer comes out to be, it's 6 into 5 into 4 into 3 factorial divided by 3 factorial. So this pretty much goes out and my answer is 120 such numbers can be formed. Easy, isn't it? You can do the question in such a easy manner. Believe me, you will be spending a lot of time thinking of all the cases and making your life difficult. But this makes your life pretty simple. Let's suppose if I ask you a question, there are digits 1, 2, 3, 4, 5. Okay, in how many ways can you form 5-digit numbers such that the tens digit has to be greater than the hundredths digit? So it's 5 factorial by 2 factorial, isn't it? Just divide it, the total number of ways divided by the total number of identical things and how many ways they can arrange themselves. So this would definitely give you an answer, a straightforward and an easy answer. So I hope you've understood this. Let's move to the next question. In how many different ways 8 boys A, B, C, D, E, F, G, H can stand in a row such that A should stand to the left of D and E and E should stand to the right of G? I think we have done this question. Okay. In how many ways A, B, C, D, E, F, G, H can be arranged such that A, B, C should come before F, G, H? Now this question can become really awkward if you do it by making cases. But if you understand in how many ways can I arrange A, B, C, D, E, F, G, H, that would be 8 factorial, isn't it? So in how many ways you can arrange A, B, C, D, E, F, G, H? That is 8 factorial. Now there is a condition on these 3 words and these 3 words. So if ABC has to come before FGH, that means I'm assuming that these things, 6 things, can't interchange their position. So first of all, I'm assuming that let's suppose ABC and FGH are identical. So then they are going to be 8 factorial by 6 factorial. However, I can't assume ABC to be identical and FGH to be identical in themselves. So ABC can arrange themselves in 3 factorial ways and FGH can arrange themselves in 3 factorial ways. So that will give me my answer as 2016 ways. It's easy, isn't it? Let me just take a quick recap. In how many ways these 8 words can be arranged such that ABC should come before FGH? So the all total number of ways are 8 factorial, and then I assume these 6 things to be identical. That means they cannot interchange among themselves. So 8 factorial by 6 factorial. However, these ABC can interchange among themselves. That would be in 3 factorial ways. Similarly, the FGH can arrange themselves in 3 factorial ways. So the total number of ways in which they can arrange themselves is 2016. I hope you've understood this. If you understand this, the questions become so easy. You laugh at these questions, right? So it's all about making your life easy. So in the end, I would like to say that counting is systematic. It's not random. You randomly picking up a number or you're randomly arranging them doesn't mean that you should be solving this question randomly. Every question can be solved using a universal approach. So you should know the universal approach, and that universal approach can be applied to every question. So try to do those questions in a universal approach, and you would see after some time and after some practice, the questions become easy. You start looking at those questions in a universal way rather than looking each question in a different way, right? So I hope you've understood this. It's a very difficult concept to understand for once, but once you understand this, life becomes so easy. These questions become so easy for you to solve it. So this was the second video on permutations and combinations. I'll be posting more videos because there's more concept to cover. I'll take rest only when all the GMAT, all the CAT is covered free of cost on this, right? So this is going to be an email address. Don't forget to send me a valuable feedback. I've been receiving a lot of these. Thank you very much for the feedback as well, and thank you very much, and see you next video.